Hello, welcome to our class today, 8th graders. We are taking this time to, like we said in the intro, to analyze and to make sure that we are focusing on what is really crucial first and foremost during this time for you guys as 8th graders. I know we said, solving equations is a part of that, and we will look at that more extensively next week with solving equations. But this week, especially today, right? We just have school today, Wednesday. We are going to be finishing up our unit on scatter plots and trend lines. So we talked about scatter plots and the associations and the line of best fit. And we took a CFA on that on our last day. And so today we're kind of reviewing that and then doing some practice and then trying that CFA once again if we want to improve that score, or if we didn't get it the first time or we were absent that day, this is a chance to kind of get all caught up with that. So I will have us look at scatter plots and trend lines. There should be a PowerPoint on this post that looks like this on my screen. And I usually use my other program, but we're going to use this guy for now. So if you are following along, scatter plots and trend lines, that's where we are. And you're going to follow along with your own PowerPoint opened up. So on the second slide, we say scatter plots. So scatter plots are graphs of bivariate data. Again, the prefix bi meaning two, right? And then variate being variables. So this just means two variables, right? Two variables. So what are our two variables? Well, we have an x-axis, right, going horizontally, and a vertical axis going vertically. So in this case, it looks like we have study time in minutes, and this is mark in percentage, so like score in percentage. So as we're looking at this, and let's see if we can see if I can draw in here. Looks like I might not be able to. That is okay. But we are going to go ahead and draw on this a little bit. So it says two variables, study time and percentage on the exam. So we look at this scatter plot. Okay, so each of these are an individual person's score, right? So this person studied, looks like about 70 minutes, a little over an hour, and they scored a 53 on their test. Okay, so 7 minutes, 53. These guys over here, there's a little clump here, they studied for about 93 minutes. Okay, so they studied for their test, big test, I guess, for an hour and a half or so. And they scored a 77. Okay, they all scored around a 77. So you can see from this chart, it's looking like the more they study, these students are scoring better on their exam, on their test. And clusters is one of our vocab words that we talked about. Clusters, are groups of points. Okay, so they are groups of points, and whether it's happenstance or we know it's going to happen, clusters are those groups of points, and they can tell us different things in data. So that was one of our vocab words. Another vocab word we had was outliers. And if you remember, outliers are points, single points that don't fit in with the rest of the data. So sometimes it can be just one point like we have here, or several points that are scattered around. Sometimes they're easier to tell than others. Sometimes they're harder to tell. So using the shape tool, so at the top of the PowerPoint, whether you're using Microsoft PowerPoint or you're using Google, there should be a bunch of shapes that look something like this. Go ahead and you can use the rectangle or the circle, and it might try to make it filled in like that. If it does, you can always change the shape fill to no fill, like I just did there. And it says put a rectangle or a circle, either one, I don't mind, around the outlier. So I'm going to say no fill. I'm going to make a square. Also no fill. So go ahead, pause the video. I want you to draw a rectangle and drag it to where you think the outlier is. All right, did you draw your rectangle? Were you able to get it there? If so, looking at this is a pretty strong correlation or strong association. It looks to me personally, and that's the thing with science, right? Which is applied math. It's not always going to be exact. But it looks like this guy for sure does not fit in with the rest of this trend, right? And I would say maybe even this group as well might not fit in with our group. If we have a trend line, our trend line is going to look something like this. So that's a trend. So maybe this is a bit lower. This is maybe doesn't follow our trend quite as well. So these could be possible outliers, and this one for sure is an outlier, right? So those are our outliers. All right, and we've got some clusters here, here, here. So now let's go to the next slide. So that brings us to associations. We said scatter plots often have arrangements that are called associations or trends, right? Positive associations look like a positive slope. So when we did our unit on linear equations, you guys remember that we would have things with positive slope. Oops. And they would look like that, right? And things with a negative slope, and they would look like that. Or things with no slope, right? Or things that we would say are undefined. So all of these, positive slope, negative slope, zero slope, undefined, are associations. And in this case, we have a bunch of individual data points. That's why it's a scatter plot, right? So what makes it a scatter plot is it's these individual points, scores in this case. So with all these individual scores, we look for a trend. Well, we say, okay, well, it looks like as x is increasing, y is increasing, right? And this is really crucial, guys. When you're looking at positive slope or you're looking at positive association, like we have written here, it says as one variable increases, the other increases. And it's 99% of the time, it'll be the x variable affects the y variable. For example, in this case, the more they studied affected how they did on the test, right? The x variable affected the y variable. So we would say as the study time increases, as the x increases, the score increases, the y increases. It's not the other way around, right? They don't score. It's not like because they scored an 80 on the test, they ended up studying for 100 minutes. Or because they scored 60 on a test, they now have to study 70 minutes. No, this happened before the test. It's a cause and effect. The x is the cause and the y is the effect. Okay, so really important difference to notice there. All right, let's look at this next one, negative associations. So negative associations look like a negative slope. So if we were talking about, again, whether it's a linear equation or in this case, a scatter plot, negative associations look like a negative slope, so going down, right? As the x is increasing, the y is decreasing this time. So as x gets bigger, y is decreasing. That is a negative slope. So in this example, let's see. I want you guys to pause the video and try to say to yourself out loud, what's going on here? What's the trend that you notice? So pause this, figure it out, and then see if we get the same thing. All right. So what did you figure out? Did you think that as cholesterol consumption is increasing, life expectancy is decreasing, right? So the more cholesterol they eat, basically, the more cholesterol they eat, the less likely they are to live longer, right? They're more likely to die early if they're eating more cholesterol, right? And we see it has a little bit of impact here, but if they're eating a lot of a lot of cholesterol, then it's going to affect their life expectancy, how long they're going to live. So this negative correlation, and it looks like a pretty strong graph here, right? Do we notice any obvious outliers? Not really, right? Maybe there's, one here or there, but it's all together in one clump, one cloud, so to speak, and it's a pretty obvious trend. Okay, so, and again, the X affects the Y. And for negative correlation, as the X increases, the Y decreases. Because life expectancy doesn't affect how much cholesterol you're going to eat, right? You're not like, oh, I'm not going to live very long, so I'm going to eat a ton of cholesterol. No, it works the other way around. So, all right. What about this next one? We got 3 more. No association. It looks like random points scattered across the graph. There's no relationship between the points. Okay? So even though you might say, well, maybe they're really scattered, but there's maybe a upwards trend here, it's not enough. It's not close enough to really tell what's going on, right? We can't say, oh yeah, it sounds like the number of siblings affects their grade on this chart, right? It says their grade, let's say, their student grade. It doesn't matter how many siblings they have. That's not going to affect what grade they're in. Or if this person's in 7th grade, it doesn't affect how many siblings they have, right? What grade you're in doesn't affect how many brothers or sisters you have. So there's no correlation, and we can maybe figure that out. But looking at our scatter plot, these people that were interviewed, we can say, hey, there's no cloud or trend going up or going down. So there's no association. Okay, so very random. That's what the keyword is there. All right, trend lines. So we talked about scatter plots, right? It's plotting 2 points of data. Okay, we talked about clusters, okay, and then outliers. And we talked about negative correlation and positive correlation. Positive correlation, negative correlation, and no correlation. So the last thing we haven't talked about is trend lines. So trend lines are lines that represent the data on a scatter plot. It is close to as many points as it can be while being a straight line. So it can't be curved. It can't be separated. It has to be a single continuous line. And if it is a single line that tries to cut through as many points as possible, we call that a line of best fit, right? Line of best fit. So if you want, you can type that in on your PowerPoint, a line of best fit. And does it have to go through 0? Does it have to go through our origin? See if you can remember back and think. Okay. Did you answer that you don't have to? That is the correct answer, okay? So your trend line doesn't always have to start here and then go either up or a little left or a little more right or a little more right. This trend line can start anywhere and just really go through as many points as possible, as long as it's a single line and we're trying to split as many points as possible. And look here, we've got 1, 2, 3, 4 on this side, and 1, 2, 3, and almost 4 on that side. So that's pretty good. That line is going almost directly through our points. So, and you can use this trend line to make predictions, okay? The points represent the actual data, while the line represents an approximate, right? So we can say, oh, okay, even though we don't have a point that says someone that did 2.5 miles, it took them 25 minutes. Even though we don't have the data, we can assume that if this trend continues, that, yeah, if someone ran 3.5 miles, they didn't do that today, but if they ran 3.5 miles, they'd probably take them 35 minutes, according to this graph in this group of runners, okay? So making predictions from that, this is the last thing. To make a prediction, we follow the prompt and based on the data, choose our best point. Okay, so here's our example. What is the best prediction for y when x is equal to 72? Okay, what is the best prediction for y when x is 72? Okay, we don't have that point plotted on here, but if we had to predict or guess what would happen, what would we get? Okay, pause the video now and see if you can answer that. All right, did you get, let's see what we got. We got 72 for x, so if we're right about here, then our y, is our y going to be 61, somewhere around there, or is it going to be 96 up here? Well, if it was up here, that'd be an outlier. That wouldn't really follow our trend, would it? So it's got to be 61, right? It's got to be 61. So if x is 72, we can assume y is going to be somewhere around 61. And it's not exactly 61, right? We're guessing. But we're using scientific process to guess, make an educated guess. All right, so the challenge, I want you to use the drawing tools and add a line of best fit to this graph. Okay, you can use your tool up here, something like this that looks like an arrow, and draw it on your graph. Okay, pause the video now and see if you get it correct. All right, so if I'm drawing a line of best fit, I don't have to start in my origin down here, right, do I? So as long as I'm trying to cut my points in half, then I'll have a line of best fit, something like this. Okay, that would be my line of best fit. Let's see, I've got 1, 2, 3, 4, 5, 6 points over here, 1, 2, 3, 4, 5, 6 points over there, and 1 in the middle. That's a pretty good line of best fit. Okay, if yours looks something like that, then you did a great job and you got your line of best fit. Trying to split through the clouds, split through the points, data points to get our trend line there. Okay, and we notice this is a negative correlation because as x increases, y decreases, right? Alrighty, so now it's your turn, guys. You're gonna follow the links below to do a couple practices on IXL. Okay, these will work pretty quickly because all you're doing is recognizing associations and working with scatter plots. And as you try to practice it, if you look at which ones you get wrong or ask me for help, you will start to get these really, really quick. Okay, so these should have hyperlinks. If you are in the PowerPoint, you can just click Control and then click on here, and it'll take you to the practice set. I'll show you that. So you are going to, and let's see if I can underline this, try to get a SMART score of 90 on each of these, okay? A SMART score of 90 on each of these. These two right here, okay, this one and this one, you guys have already worked on, okay, or should have already worked on at least. We did CC dot and CC dot 14, and we got those to 80 on both. Okay, so you should be very close on these, but I want you to try to get these to 90, okay, and then try these last couple here, okay, recognizing outliers and making predictions with scatter plots, okay. So once you get all 4 of these to 90, then I want you guys to go ahead and head to the CFA that I'm going to post on Classroom, and once again, you guys mainly you took yours or should have last week, but if you did not or you want to retake it, let me know if you need to retake it and I'll reset your answers. Or if you did not take it, you needed to make sure you take that for the first time. Okay, so what do you need to do? 1, 2, 3, 4 IXLs. You can highlight each of these once you check them off to help you keep track. And once you get each of these to 90, then you go in, I'll have the CFA ready for you to take it, and then you'll be done. Okay, I think you guys will do great. It, again, should go pretty quick. Let me know if you need any help, okay? And if you're looking at how to get these, you press Control and click on one of them. So if I'm working on DD8, it'll take me right there. Make sure to sign in so I can see your score and I can give you points. And this one, it says, look for which one has the outlier highlighted. Well, this one's in the middle of the data. Oh, this one's way out there. Okay, that's the outlier, right? So make sure you sign in when you do those, and they should go pretty quick. I'm already at 12.